Welcome to the Midday Roundup for May 1st, 2025. I'm Maya Hayes.
And I'm Julian Vance. Today, we're doing a deep dive into some really interesting developments in AI, tech, and also space news. We'll pull out the key insights for you.
Yeah, we've gone through a bunch of articles, reports, you name it. The idea is to give you a shortcut, really, to understanding what matters in these fields.
Make sense of it all without getting bogged down. So let's jump into AI first.
Sounds good. Where are we starting?
Well, one area that's getting a lot of attention is how to secure the sensitive data AI often works with. Let's talk about confidential computing.
Confidential computing. Okay, sounds important. What's the core idea there?
So fundamentally, it's about protecting data by processing it inside these special isolated hardware environments. They're called trusted execution environments, or TEEs.
Okay, T's, isolated environments.
Exactly. And the really critical part is the data stays encrypted, not just when it's stored or, being sent somewhere, but even while it's in use, while the computer is actually working on it.
Oh, wow. Okay, so encrypted during processing. That's different.
It's a big step up in security. Itai Schwartz, he's the CTO at Mind, really emphasized how vital this is for AI, especially where you have collaboration happening in, like, decentralized systems.
Right, because AI models might be running in different places, maybe controlled by different groups.
Precisely. And you need to trust that data is safe wherever it's being processed. Schwartz also mentioned remote attestation. That's a feature that basically lets you verify the T is secure before you send sensitive work its way. Supports that whole zero trust idea.
Zero trust, meaning you don't automatically trust any part of the system.
You verify everything, yeah. Now, it's important, Heath Renfro, the CISO at Phoenix 24, made a good point here.
What was that?
He stressed that confidential computing isn't like the silver bullet. It's not meant to replace all your existing security.
Ah, okay, so it's an add-on.
Exactly. It augments things. Think of it as another strong layer. He also highlighted the benefits for meeting regulatory requirements, compliance, and for enabling secure projects where multiple organizations need to share sensitive data.
That makes sense. I can see that being huge in finance, healthcare, maybe the public sector too.
Definitely. Anant Adya over at Infosys specifically mentioned those. He gave a great example. Banks working together on fraud detection. They can pool insights using confidential computing without ever exposing the raw customer data to each other. Preserves privacy, but boosts security.
That's a really clever application. So if a company wants to adopt this,
Yeah.
it sounds potentially disruptive. How do they approach it?
Good question. Both Renfro and Adya recommended a phased approach. Don't try to boil the ocean.
Start small.
Yeah.
Huh?
Renfro suggests identifying the most sensitive workloads first. Maybe stuff involving regulated data or data crossing borders. Put those in T's initially.
Okay, prioritize.
Then you integrate it with your existing security stack, your identity management, your data loss prevention tools, encryption, all that. Adya echoed this, suggesting starting with high-risk data, like financial transactions or health records.
And you mentioned these keys have secure enclaves. Can those be used for other sensitive things, like, say, encryption keys?
Absolutely. Those enclaves are perfect for storing super-sensitive secrets, like PKI keys or digital certificates. Adds another layer of protection right there.
Okay, the security benefits seem pretty clear. But are there downsides? Any trade-offs?
Yeah, the main one people talk about is performance overhead. That isolation that makes T's secure, it can add a bit of latency.
Ah, so it might slow things down slightly.
Potentially, yeah. And scaling it up needs careful planning compared to standard computing.
So how do you balance that? You want the security, but you need the speed too.
Renfro's advice is to focus those T resources where they'll have the biggest impact. Target the workloads with the absolute highest confidentiality needs.
Like complex financial modeling, maybe? Or AI training on really sensitive data sets.
Exactly those kinds of things. Maximize the security benefit where it matters most.
It also sounds like this could really help with navigating all those complex data privacy laws, like GDPR or CCPA.
Definitely. Renfro pointed out that mapping confidential computing features to specific regulations can make audits much simpler and really strengthen your compliance.
Makes sense.
And Adya stressed the need for internal teamwork. You need IT security, cloud architects, data governance, compliance folks, all working together.
Right. It touches a lot of different areas. So for businesses dealing with lots of sensitive data or in heavily regulated industries, this is becoming well, almost foundational.
It's heading that way.
Yeah.
And CIOs are going to be key in driving this adoption.
How so?
Well, as Renfro sees it, they need to guide the integration, make sure it fits with existing systems, get the different departments collaborating, and really tie it back to business goals.
Show the value.
Exactly. Show measurable results like reduced risk, maybe faster onboarding for partners because the data sharing is secure, or, like we said, easier audits. That demonstrates the real business value.
Okay, let's switch gears slightly within AI. Salesforce research has been talking about something they call jagged intelligence. What's that about?
It's an interesting concept. Salesforce is basically acknowledging something many people have noticed about current large language models, LLMs,
Which is?
that while they can be incredibly good at some things, acing tests, writing poetry, whatever, they can also stumble when you ask them to perform tasks reliably in a messy, dynamic business context.
Ah, so they're smart, but maybe not consistently dependable for real-world business jobs.
That's pretty much it. Silvio Civides, he's the chief scientist at Salesforce, described it as this jagged profile, high peaks of capability in some areas, but valleys where reliability for specific tasks falters.
Okay, jagged intelligence. I get it.
So Salesforce's research is focusing less on just making the AI smarter in a general sense, and more on making it consistently reliable and trustworthy for enterprise tasks. Consistency over raw smarts, you could say.
That focus on reliability seems critical for businesses. Are they rolling out new tech based on this?
They are. They've announced new benchmarks, models, frameworks, all aimed at boosting that intelligence, trust, and versatility for business use.
When can we expect to see this?
The first bit, something called SFR-Embedding, is heading to their data cloud platform soon. Other innovations are planned to power future versions of their Agentforce product.
So they're actively building tools around this reliability principle, and Severies had a quote about the human role in all this.
Yeah, it was quite pointed. He said, it's not about replacing humans, it's about being in charge.
Hmm. So AI as a tool to empower people, not replace them.
That seems to be their vision, yes. Keeping humans in control.
Okay, moving on. Microsoft Research also made waves recently with something called 5-4 Reasoning Plus. What's the story there?
This is another fascinating development, mainly because it's a small language model, only 14 billion parameters.
Small compared to giants like GPT-4, right?
Exactly. But the key thing is, it's specifically designed for deep structured reasoning. And importantly, Microsoft released it with open weights.
Open weights meaning?
Meaning the underlying model parameters, the core knowledge it learned, are publicly available. Anyone can use it, study it, build on it.
Okay, so small but powerful for reasoning and open. How did they achieve that?
It builds on their earlier 5-4 model, but they've enhanced it with specific training techniques, supervised fine-tuning, and reinforcement learning aimed squarely at boosting performance in math, science, coding, logic. Tasks that need step-by-step reasoning.
And the training data was specific, too.
Quite specific. Around 16 billion tokens, lots of unique synthetic data and curated web content, plus a reinforcement phase focused just on math problems. For context, tokens are like the words or parts of words the model processes.
And the open weights come with a permissive license.
Yes, an MIT license. That allows for broad commercial use, fine-tuning integration with standard tools like Hugging Face transformers. It's part of this Microsoft trend of pushing smaller, efficient models that can punch above their weight.
It's pretty remarkable that a smaller model can compete with or even beat larger ones on certain tasks.
It really is. Reports show 5-4 reasoning plus outperforming much larger open-weight models like DeepSeek R1 to still 7dB on some tough reasoning benchmarks. They mentioned its accuracy on a specific math exam benchmark, for instance.
So what does this mean for businesses, for the tech decision makers out there? Why should they care about this smaller model?
Well, several reasons. First, it offers high-level reasoning without needing the massive, expensive infrastructure that the giant models demand.
It's huge.
Lower cost, easier deployment, potentially.
Right. And the open nature and compatibility mean more flexibility in how you deploy it across different tech stacks within a company.
It has a decent context window, 32,000 tokens, potentially expanding to 64K. That makes it useful for tasks involving long documents. Think legal reviews, technical Q&A, maybe financial analysis.
So it can remember more of a long document while working.
Essentially, yes. Also, the way it separates out its reasoning steps, its chain of thought from the final answer, could make it easier to integrate into systems where you need to understand how it reached a conclusion. More interpretable.
And easier to use on less powerful hardware.
Potentially, yes. easier to slot into pipelines with limited resources. Plus, it seems to generalize well to problems it wasn't explicitly trained on, even complex ones. And it has built-in safety features.
Okay, so 5.4 Reasoning Plus feels like a signpost towards AI becoming more accessible, more affordable, customizable, without sacrificing that crucial reasoning ability.
I think that sums it up well. It represents a really interesting trend towards powerful but smaller and more open models.
Let's talk about AI integration into things we use every day. Google Search is making some big moves with its AI mode, right?
Yeah, they're definitely pushing it forward. They've dropped the waitlist in the US for people already in their labs program.
So more people can access it now.
Right. And they're even testing putting an AI mode tab directly in the regular Google search results for some users. It's a small test for now, but shows the direction.
Clearly taking aim at competitors like Perplexity AI or ChatGPT search.
Seems very likely. They're also adding features within AI mode. You can now pick up where you left off in a previous AI-driven search.
Oh, that's handy. Maintains context.
And they're adding more visual elements like cards for places or products to give you more details, restaurants, travel gear, that kind of thing.
And I heard something about helping with shopping decisions.
Yes. So if you ask a complex shopping question, like, find me the best foldable camping chair under $100 that fits in a backpack,
Okay, specific.
AI mode will give you a breakdown of recommended products, list key features, and even provide direct links to buy them. It's moving towards facilitating action, not just giving info.
Sticking with Google, but shifting slightly, they're apparently putting ads inside chats with some third-party AI chatbots now.
That's the report, yes. Google's AdSense network, their big advertising platform, is now supporting ads appearing within conversations on some chatbot websites. They tested it with a couple like iAsk and Liner.
So while you're chatting with an AI, an ad might pop up in the conversation flow.
That seems to be the idea. A Google spokesperson basically confirmed that AdSense for search is available for sites using conversational AI.
Interesting. Trying to monetize this shift towards chatbot interactions for information.
That's the logical conclusion.
Right.
As users increasingly turn to chatbots instead of traditional search for some queries, Google needs to find ways to, well, get in on that action and protect their ad revenue.
It follows their investments in their own AI, like Gemini, and putting ads in their AI overviews and search results earlier.
Exactly. It's all part of adapting their business model to the rise of AI.
Okay, different platform, different AI issue. Pinterest. They're adding labels for AI-generated images. Sounds like a response to user complaints.
It definitely seems that way. Pinterest is rolling out features to help users identify and potentially filter images made or heavily edited by generative AI.
How will that work? What will users see?
When you zoom in on a pin, if their system thinks it's AI modified, you'll see a little stamp in the corner saying AI modified.
How do they know if it's AI?
They're looking at image metadata, first things like Google SynthID or Adobe's content credentials, which are like digital watermarks.
If the creator embedded that info.
Right. But they also say they've built their own classifiers to detect AI content, even without those markers. And importantly, there's an appeal process if a user thinks their pin got wrongly labeled.
That's crucial. And this is because users were finding too much AI content.
That seems to be the main driver. Users were reportedly frustrated, finding it harder to locate genuine photos, real-world inspiration, or actual products they could buy because of the flood of AI images.
Yeah, I can imagine. Especially if the AI images show things that look real but are actually impossible to achieve or buy.
Exactly. That deceptive realism was another concern mentioned.
And finally, on the AI front, even Wikipedia is getting involved. Integrating generative AI, that sounds potentially controversial.
Well, the Wikimedia Foundation is being very careful about how they're doing it. The key point is they are not using AI to write articles.
Okay, that's important. So what is it doing?
It's intended as a tool to assist the human volunteer editors and moderators.
Assist how?
Chris Albon, who directs machine learning there, put it nicely. He said, AI won't replace humans, but it can help remove technical barriers. Think helping with background research, translating articles, maybe making the onboarding easier for new editors, routine tasks.
So it frees up the human volunteers for the more complex work, like ensuring accuracy, neutrality, that kind of thing.
Precisely. They already use AI for things like spotting vandalism or checking readability, but the sheer volume of information is growing so fast, it's hard for volunteers to keep up.
The AI eating Wikipedia alive concern.
That's a real concern, yeah. They're also trying to manage the huge amount of traffic they get from AI bots scraping their content. They've launched an initiative to create an open data set of structured Wikipedia content to help research ways to manage that bot traffic better.
Okay, that wraps up a packed AI segment. Lots happening with security, model capabilities, and how AI is weaving into platforms. Let's pivot now to outer space. An update on the hunt for Planet 9.
Yes, this is quite intriguing. A potential new candidate for this hypothetical hidden planet has emerged, and it comes from analyzing, believe it or not, very old sky survey data.
Old data. How old?
Infrared data collected 23 years apart.
Yeah.
An international team went back and looked for subtle signs.
And they found something suggesting a planet way out beyond Neptune.
Potentially. Their analysis points to an object maybe 5 to 10 times the mass of Earth,
Wow, a substantial planet.
and on a huge orbit, taking perhaps 10,000 years to go around the sun once.
It seems incredible something that big could have been missed.
Well, Gary Bernstein, an astronomer commenting on it, noted that even a Neptune-sized object would be incredibly faint at those vast distances, easy to overlook.
And the whole idea of Planet 9 comes from weird patterns in the Kuiper Belt, right? That zone of icy objects out there.
Largely, yes. Some objects in the Kuiper Belt, like Sedna, had these strangely clustered, elongated orbits. One explanation is the gravitational tug of a large, unseen planet.
So how did this team use the old data to look for it?
They looked for things that moved very, very slowly between the two observation times, 23 years apart. A distant planet would appear as maybe just a pair of faint dots in slightly different positions.
And they found potential pairs.
They found 13 candidate pairs, but one pair really stood out because the object had the same color and brightness in both observations, which makes it a more plausible candidate.
Must have been a eureka moment for them.
The lead author, Terry Longfan, expressed a lot of excitement, but it's important to temper that a bit. The broader scientific community is still cautious.
Skepticism remains. Why?
Well, the signals are extremely faint. There's always the chance it's just noise in the data, or maybe unrelated faint objects lining up by chance.
Okay.
And some astronomers aren't fully convinced that the weird Kuiper Belt orbits require a Planet 9. Samantha Lawler, for example, argues there might be other explanations, especially since we haven't observed that many of these distant objects in detail yet.
So, intriguing evidence, but not definitive proof yet. Is there anything on the horizon that could settle this?
Yes, definitely. The Vera C. Rubin Observatory, currently being built in Chile, is a game changer.
How so?
It's expected to survey the sky much more deeply and widely than ever before. Astronomers think it could find tens of thousands of new Kuiper Belt objects.
Wow.
That huge increase in data should give a much clearer picture of the outer solar system and could either provide much stronger evidence for Planet 9 or potentially rule it out. We should know a lot more in the coming years.
Well, that brings us to the end of our deep dive for today. We've covered a lot, from the intricacies of securing AI with confidential computing
To the push for more reliable AI, with concepts like jagged intelligence and the rise of powerful small models like 5.4.
and how AI is changing search, advertising, and even platforms like Pinterest and Wikipedia. Then capped off with the tantalizing, though still uncertain, possibility of a hidden planet in our own cosmic backyard.
It really shows how fast things are moving, doesn't it? Both the digital realm of AI and in our exploration of the physical universe.
Absolutely. We hope this gave you a clearer picture of these key developments, those aha moments, without needing to sift through everything yourself.
So maybe a final thought to leave you with. As these AI models, even the smaller ones, get better and better at reasoning, what new ethical questions does that raise about their use and deployment?
And on the space side, what would finding a ninth planet, or definitively proving there isn't one, really mean for our understanding of how solar systems form and evolve? Lots to think about. Thanks for joining us.